How are you all doing? Hope you are doing great today. I appreciate the fact that you took time to watch my presentation. For those of you who do not know me, I'm Dr. Nandi. I go live on YouTube frequently solving math problems. I also have fun YouTube videos in my shorts. If you take a look at my channel, take a look at my fun shorts, and you also please take a look at my other math videos that I have posted where I've solved problems or lectured on a topic. And if you like my videos, please give me a thumbs up and please subscribe to my channel by hitting the red subscribe button. And please do not forget to hit on the bell button to get a notification whenever I upload a new video. So without further ado, today we are going to solve a problem on sampling distribution of sample means. So uh, what is sampling distribution? It's a probability distribution of the sample means. Okay, so you have sample mean on the horizontal axis or x-axis. On the vertical axis you have relative frequency, and this is usually a bell-shaped curve. The larger the sample size, the smaller is the spread of this bell-shaped curve. So we're talking about sampling distribution or probability distribution of sample means. It's a bell-shaped curve, provided we have a large sample size. So here's the problem. An airplane with room for 100 passengers has a total baggage limit of 6,000 pounds. So this is the key to this problem. The total baggage limit that the plane can carry with 100 passengers is 6,000 pounds. Okay. Suppose that the total weight of the baggage checked by an individual passenger, one passenger, is a random variable. That is, the weight of the luggage checked by one passenger is a random variable with a mean of 50 pounds and a standard deviation of 20 pounds. So if you think about it, this is the probability distribution of baggage weight checked by an checked by an individual passenger checked by an individual passenger one person. Okay. It's a random variable with a mean of 50 pounds and standard deviation of 20 pounds. So on the horizontal axis is the baggage weights, and that's a random variable. X on the horizontal axis. So on the vertical axis you have probability. It's a bell-shaped curve. You can assume it has a mean is the point on the horizontal axis where the probability is the highest. The mean is 50 pounds and the standard deviation is 20 pounds. Again, mean is the center where the relative frequency of probability is the highest value. Sigma is the standard deviation or an average variation from the mean of the baggage weights. If 100 passengers will board a flight, what is the approximate probability that the total weight exceeds the limit? So the total weight when it is greater than 6,000, total weight of baggage when it is greater than 6,000 will exceed the limit. Pounds will exceed the limit. Exceed the limit or exceed the restriction. Total weight of baggage checked by 100 passengers. 100 passengers. That means mean weight or average weight of luggage checked in would be 6,000 pounds divided by 100 passengers. Okay, 6,000 divided by 100, these two zeros cancel with two zeros in the right, or you can use your calculator. 6,000 divided by 100 is 60. So mean weight of the luggage checked in would be greater, I should write down, greater than 6,000 pounds divided by 100 passengers is equal to 60 pounds per passenger. When the mean weight exceeds this, mean weight of luggage exceeds this amount, the plane can crash. When luggage exceeds this amount, it is beyond the limit. Remember, the limit is 6,000 pounds. Limit is 6,000 and 100 passengers. It exceeds the amount. When the mean weight of the luggage exceeds this amount, it is beyond the restriction, and there is chance of crashing. You don't want that. Beyond the limit. So in this case, we are dealing with probability distribution of sample mean. Probability distribution of sample mean luggage weights. And that's where we will apply the central limit theorem. And this is also bell-shaped. It looks like this. You have X bar, mean luggage weight, on the horizontal axis. Mean luggage weight. This weight on the horizontal axis. Okay. And this is bell-shaped, but it is tall and narrow and thin. Okay. And its center, the center is where the peak is the highest. So if I draw a vertical line to meet the center, this is the mean of this distribution, mu x bar. Okay, this is the probability distribution of sample mean luggage weights, which is on the horizontal axis, and of course you have probability on the vertical axis. By central limit theorem, the mean, this is the sampling distribution, right? This is the sampling distribution. You have, the difference is you have X bar or sample mean weights on the horizontal axis. So you have this is the sampling distribution. By central limit theorem, the mean of the sampling distribution, mu x bar, is equal to mu, and that is given as mean weight of 50 pounds. Okay, and sigma x bar, which is the standard deviation of the sampling distribution, is sigma divided by square root of n. This comes from central limit theorem. Now sigma for one particular passenger is 20 pounds, and our number of passengers is 100. So square root of 100. Now square root of 100 is 10. So it is 20 divided by 10 or 2. So the center is mu x bar is equal to 50, and we already discussed if it exceeds 60 then it will be beyond the limit. So the center is 50, 60 is a number greater than 50, so 60 will be somewhere over here on the right of 50, and we try to find out what is the probability that x bar will be greater than 60, that is on the right of 60. Remember, this is the 60 point and we want greater than 60. So remember, this curve extends to 1e99 on the right. That means 1 followed by 99 zeros, which is a very large number on the right. Why do I need that information? Because I will use TI-84 to find out the area or the probability of x bar greater than 80. So I'm going to use TI-84 calculator. My goal is to find out what is the area under the normal curve on the right of 80, on the right of 60. Because total number of luggage is 6,000 pounds, total amount of luggage divided by 100 passengers. So average weight of luggage per customer is 60. The mean is 50, standard deviation is population standard deviation, which is 20 divided by square root of sample size. And that's where central limit theorem is coming in. 20 divided by square root of 100 is 20 divided by 10 is 2. That's why this curve is much narrower, because sigma x bar is only 2 as compared to the single passengers weight distribution, luggage weight distribution, which sigma is 20. Now we want to find the area to the right of 80. So to the right of, sorry, I'm telling 80 here, right of 60. What is the probability that the average weight of carried by each passenger exceeds 60? So we want to be on the right of 60. We draw a vertical line at 60 on the horizontal axis to make the bell-shaped probability distribution curve or sampling distribution curve, and we want to find the area to the right of 60. So we go like this. We go to TI-84, press the second button on the top left, then the verse button in the third row, second verse, and then number 2 for normal CDF. C stands for cumulative distribution function. It finds the area, okay, under the normal probability distribution, hence normal CDF. C stands for cumulative area, okay. Our lower, we are starting our calculation from 60, so we will type in 60. Our mean is a very large number on the right, 1 followed by 99 zeros. Remember, this curve stretches to infinity on the right, which we tell the calculator by 1 followed by 99 zeros. So we type 1, then we press the second button, then we press the comma button, which is on top of the 7 button. That will give you the small cap E, and then you type 99. 1 followed by 99 zeros is a very large number on the right. What is your mean? Your mean is 50, same as the population mean. So let me change that to 1 second comma 99. Your mean is 50, so I'm changing the mean to 50, same as the population mean. But the standard deviation, we do not plug in the standard deviation of the population. It is the standard deviation of the sampling distribution, which is the standard deviation of the population divided by square root of the sample size, square root of 100. So 20 divided by 100 is 2. So let's plug in for the standard deviation 2. So the mean is same as the mean of the population, however the standard deviation of the sampling distribution is only 2, whereas the standard deviation of the population is 20. Why it is 2? Because it is standard deviation of the population, which is 20 divided by square root of sample size. We have 100 passengers check-in, so n is 100. 20 divided by square root of 100 is 10, hence it is 2. 20 divided, so it is 20 divided by 10 is 2, okay, and we go paste, enter and enter, and that probability value is very low. it is 2.8 e minus 7. What does it technically mean? Is equal to 0.060 3, 4, 5, 6 and then 2. This is almost equal to 0. So there is very small probability of point decimal followed by 6 zeros and 2. That's almost equal to 0. Or very low probability that the sample mean will exceed 60. How did you get 60? 6,000 is the total weight restriction divided by number of passengers, 100. So the mean weight per passenger is 60. And we just found out the probability of the mean weight exceeding 60 is very small under the circumstances. What does it mean? It means most of the sampling distribution area is in the center and very little in the tail region. Okay? Or in other words, all the sample means are very close to the population mean. Okay? So hence the probability of exceeding a large number, exceeding a sample mean weight of 60 is very small. Okay? So what people make mistake is to use an incorrect value for the sampling distribution standard deviation. It is the population probability, population standard deviation divided by square root of the sample size. Most people will make a mistake of using just the population standard deviation for this calculation, which is wrong. It is the population standard deviation divided by square root of the sample size. In this case, population standard deviation is 20 for one passenger divided by square root of the sample size, which is 100. 20 divided by square root of 100 is 20 divided by 10 or 2. Notice how small is the standard deviation of the sampling distribution compared to the samples population standard deviation. In other words, the sampling distribution curve is very narrow, wholly concentrated around the center. It's tall and narrow, very little area in the tail. Or in other words, it means most of the sample means will fall close to the mean of the population, which is 50. Or in other words, very little chance or probability of exceeding a mean weight of 60. Therefore, the plane is within the safe restriction of its maximum weight and will not crash. Okay, so I'm going to stop here. If you have any question, comment, please write me a note. I will answer to each and every one of your questions. Okay, and please let me know where you are watching my video from. It is always very interesting to know where people are living, where they are watching my video from. If you have any question, shoot me a question. I'll respond to you. If you like my video, please give me a thumbs up. If you like my video, please share with your friends. You and your friends, please subscribe to my channel. That means a lot to me. Please give me a thumbs up and subscribe to my channel by hitting the red subscribe button. That really means a lot to me. And it gives me the motivation to keep on producing more videos just for you. Again, thanks for watching, and please also at the time of subscription click on the bell button. It will notify you every time I upload a new video, which I do almost every day. Again, please do not forget to watch me tomorrow when I will upload another new video. Again, thanks for watching. Take care and have a nice rest of your day. Take care. Bye bye.